Our next speaker is coming up to us from Symantec, and he's going to talk a bit about scaling out data management. And he's going to be doing, he's a very daring man who can actually demo things live and in person.
We'll see.
Keith Neustadt, who's going to be showing us a little bit about MagnetoDB and scaling data in OpenStack. Good luck.
Thanks. Good. We're set up. Hi, my name is Keith Neustadt. I'm from Symantec, and I'm going to be talking to you guys a little bit about MagnetoDB today. MagnetoDB is a new OpenStack project. We're working towards incubation right now. It's a NoSQL database delivered as a service. But before I get started, I want to tell you a little bit about how I came to be here, because I actually started my career as a Windows application developer, right? So pretty far away from where we are today. And my first opportunity to work with the cloud and with web services was about 8 years ago on a product called Norton Family. So Norton Family is a parental controls application that allows you to install a client, an agent on all the different devices that your kids use, whether they're Windows or Mac or Android or iOS, whatever it is. And then you can go to any computer through a website and you can manage them. You can manage their policy, you can see where they're going, you can see who they're talking to. And as we started to build this cloud application, we started to realize that a lot of the capabilities that we were building into that were capabilities that any cloud application that Norton might develop would need. And so we started to separate that stuff out into what we called the Norton Management Platform. And the Norton Management Platform would allow you to do things like log in to start with, right? Any web app needs some way to log in. To send a notification from the server down to any endpoint, any client, so you could wake it up so that it might do something. We provided some shared storage. We provided capabilities to synchronize data between the endpoint and the cloud or across multiple endpoints. A way to collect application events like what websites your kids are going to or who they're talking to. And we were hoping that this would happen, but we were still kind of surprised to see it happen. Once we provided this platform, there was just this incredible burst of innovation that happened, where there were products that were never cloud-enabled that suddenly became cloud-enabled. And there were products that we had wanted to do for a long time, but we just never had resources to do because it was very expensive to build these capabilities into each of them. All of a sudden, they were greenlit. And then there were other products that we had never planned on doing, we had never even thought about, but since we had developers that were playing with these platform tools, the ideas happened, and they just sort of got built. And so we thought we were delivering a platform, and really what we were delivering was a way to innovate, right? A way for the application teams to build something new and quickly. And I thought that was really cool. And so from there, I got the opportunity to move to a new team that we were starting at Symantec that was doing something much, much broader, similar but much, much broader, called Cloud Platform Engineering. And what we're doing is we're building, it's a Symantec-wide product, we're building everything from the ground up. So we're starting with new data centers, new hardware, new networks. And then on top of that, we're layering infrastructure as a service. And we're using OpenStack for the most part for that. And then we're delivering some platform services. And some of those platform services come from OpenStack and from the community. And there's other services that weren't available, and we thought that they were important to our customers, our internal application teams. And so we started to work on them ourselves. One example is big data. So a lot of people don't really think of Symantec as a big data company, but we are, right? That's how we do things like stop zero-day threats. Is by collecting just an enormous amount of data from the internet and bringing it in-house and doing massive big data jobs on them to try to figure out in advance what's likely to be malicious and what's not. So there's a lot of that going on in the company. So new platform services that would allow you to basically rent time on a massive Hadoop cluster or rent time on a big Storm cluster. And again, The reason we're doing this is for all the reasons that you would expect. It's for efficiency, to be able to move more quickly, to be more agile. Me personally, I'm hoping that we're going to see the same thing that we saw out of Norton, which is this burst of innovation, because once you've taken all of these responsibilities from the application teams, which frankly they're not really good at, right? It's not their core competency. You freed them up from all that stuff. Now they can focus on what they're really good at, which is delivering really good products. And I'd like to suggest that that's probably what we're all doing here, right? Is that we tend to talk about things like virtualization and databases, things like that. But ultimately what we're trying to do is build a platform so that people who are building applications on top of it can do really cool stuff. So as we talk to our application teams, these are our customers, we asked, what's important to you guys? And everybody said one of their top priorities is a database, because everybody has data and everybody needs to put it somewhere. And so one of the first things that we started to realize as we talked to different teams is there's this question of what kind of databases do we need? And we saw a pretty stark split. Some teams want relational databases and some want NoSQL databases. And the teams that want relational databases, they want them for the reasons that you would expect, which is, first of all, they're really good for relational data. And so if they've got relational data, they need to be able to do a lot of complex joins, a lot of summary type queries. They want a relational database. A lot of teams are also, it's right in their comfort zone. A lot of teams have been working with these technologies for maybe even decades. But we also hear that they can be really hard to operate, particularly at large scale. So if they've got lots and lots of data or lots and lots of throughput, it can be hard to scale some of these technologies out, hard to operate them. On the NoSQL side, we had teams that really wanted to work with some of these new technologies. And again, the reasons were what you would expect. They talked about really large data sets, being able to scale out horizontally really well, lots and lots of throughput. They didn't need to do kind of complex queries. They were satisfied with whatever technology they were looking at. But they also acknowledged there's a learning curve, that a lot of these technologies are really new and they're changing constantly. And again, it's not necessarily what the application teams are best at, is managing these databases. And so the message we got again was, they can be difficult to operate. And so we started to realize that there was a second question that we should be asking ourselves, a separate dichotomy, which is, what kinds of models of databases, of database services should we be looking at? Customer operated versus as a service. So we've actually been talking about this quite a bit today. It's that split between, is the service on the, I think Nikhil called it the sort of the deployment plane or the provisioning plane, right? The provisioning plane, or is it on the data plane, right? So on the provisioning plane or on the operational plane, we as a platform, we provide services that help you operate the database, help you deploy it, help you back it up, help you manage it. But ultimately, when we hand the database over to the application team, it's theirs. They have to operate it. They have to tune it. They have to scale it. They have to manage it. They deploy it using our tools, but it belongs to them. And we've got a lot of teams that want this model because they want to get their fingers into the database. They want to make it specific to their application, tune it for their application. But then we've got other teams that they don't care. They've just got data, and they need some place to put it. And in this case, we started to think about where the platform delivers the database. The database is the service, right? The service is on that data plane. And the application teams, they don't have to worry about deploying. They don't have to worry about scaling. They don't have to worry about operating. They don't even care what the database is. They just need to know that if they call an API and they put data there, they call another API to get it back, it'll still be there. It'll be there across zones. It'll be there across data centers. So for the customer-operated model, absolutely, we're going to go with Trove. It's the right technology. For the as-a-service model, we decided that there was something new that we needed. So we partnered up with Mirantis, and we started to work on something called MagnetoDB. Again, it's on the NoSQL side, and it's on the data plane side. So the way it works is that me as an application team, if I want to store some data, I go to Keystone, I authenticate, and then I go off to MagnetoDB, and I create a table. I don't have to provision anything. I don't have to define anything. I just go off and I create this table. And once I have the table, I can start to do things like load it with data. I can do queries against it. I can make decisions about what level of consistency I want, different kinds of data types like maps and sets. And again, without worrying about what the database itself is. So our model is fully open source. We're complying with all the OpenStack standards. Again, we're trying to work our way into incubator status. Our focus is on very large data sets, lots of throughput, low latency. We want to be out there on the production line feeding web services. We're secure multi-tenant, right? So again, since we're not handing the database over to somebody else to manage for themselves, since this is a shared database, we need to make sure that we're keeping everybody's data and everybody's quality of service nicely contained. And again, integrated with Keystone. So from a very high level, it's a simple architecture and a pretty common one inside of OpenStack. Got an API proxy layer, which delivers a simple REST-like web service API. If you guys are familiar, people familiar with DynamoDB? Anybody? A few people? A couple people? Very similar to DynamoDB. We borrowed a lot from DynamoDB, although we've added to it too as we've gotten specific requests from our application teams. And there's a driver layer so that you can support different back-end databases if you want to. The database layer, we're using Cassandra and we're implementing the Cassandra driver. But there's also an H-based driver in the works. There's talk about other drivers like Mongo. So if anybody's interested, particularly on the driver side in supporting different kinds of databases, come and talk to me. We'd love to have you participate. So I'm not going to go through all of these, but just to point out a couple of ones that are I think, common ones. So just storing user data. Where are people going to use MagnetoDB? So some of our products have millions, or in the Norton's case, hundreds of millions of users, and each of these users is going to have data, profile data, or maybe settings data. This is a really good use for this kind of a database. Right, so you can create a table for your user data. You're not doing a lot of complex joins between. You're just doing very high throughput puts and gets. Another one that we've talked to teams about is to provide a searchable metadata layer on top of Swift. So let's say that you're storing photos inside of Swift. And you want to be able to look those photos up in different ways. You want to be able to say, show me all the photos that were taken by this person, or have these people in it, or were taken at this location, or between these dates and times. Right? What you can do is you can store the data in Swift and then take that link to the Swift object, store it in MagnetoDB along with all the metadata. Now you've got a way that you can search and retrieve all those objects. And we do have teams, not in that exact use case, but we do have teams that are looking at combining MagnetoDB and Swift in that way. So I am going to do a demo. But before I start, I need to ask you guys a really important question. Does anybody know what song topped the charts this time 30 years ago in 1984? Got a guess? I was 15 at the time. I would have a guess, but nobody has a guess. All right. So we're going to try to answer that question. Oh, there we go. Now people are guessing. So we're going to try to answer that question, hopefully along with a couple of other ones. So actually, before I get started, let me describe what I'm going to do. I wanted to pick a data set. In putting together the demo, I wanted to pick a data set that was a real data set, and I wanted it to be, kind of fun, right? So I went out and I found on bullfrogspond.com, they have a data set of every song and every artist that was in the top 100 for the past 130 years, I think. So a really cool data set. So what I did was I took that data set, I wrote a little bit of code that imports all that data into MagnetoDB. And like you would with any database, I defined the database based on the kinds of queries I was going to do. And so what I wound up with was two different tables. One of them is the songs table. And the songs table has every song and artist that was on the charts with summary data. Things like, what's the highest it's ever been on the charts? How long was it in the charts? When did it enter the charts? How long was the song? Things like that. And then the charts table, which is just the raw charts table. Right? So if you wanted to go and get any segment of any chart over the years, you could go ahead and really easily pull that out. So let's take a look. All right. So the first thing I need to do, of course, is authenticate, right? So let me authenticate and get my token. There it is. And take that token. I'm going to put it in my environment. All right. So now that I've authenticated, I'm going to start by doing a get to the tables resource. What that's going to do is it's going to list all the tables in my domain and in my project. And as you can see, I was telling the truth. I've got my charts table and my songs table. And now I've already created those tables, but let me show you really quickly how I did it. For the charts table, all right, I did a post to the tables resource again, and you can see that inside the post, I've named the table. It's called charts. Can you guys see the text okay? Good. So you can see here's the name of the table. It's called charts. And I've defined some, not all, but some of the columns. Now, like DynamoDB, MagnetoDB is a very flexible schema, so you don't have to define all your columns up front. But you can if you want to, and you certainly need to if you're going to use them in any sort of an index. So I've called out a couple of different columns here, attributes, things like year, week, position. And then over here for the key schema, this is basically my primary index. I've defined it as a combination of the year, right, the year of the chart, plus a concatenation of the week and the position. So again, like DynamoDB, we allow you to have indexes with one or at most two attributes. Right? So in order to get what I wanted, I took the week and the position and I put them together, and it actually works really well. I'll show you how that query works later on. Now over here for the songs table, again, you can see the name of the table is called songs. I've defined some of the attributes. Over here for my primary key, I've got the artist and the track. So I can look up any particular track by any particular artist. I've also defined a second index. So you can create multiple secondary indexes. I've named this one peak index using the artist and the highest that artist has ever been on the charts. Right? So given that, I can look for all tracks by a particular artist given how high they've made it in the charts. So once I've created those tables, that was when I went ahead and loaded all of the data. And now that I've loaded the data, I can go over here and I can start to do some queries. So again, I'm showing which era I come from. I'm going to look for Dire Straits' Money for Nothing. So over here, I've got my conditions, and my conditions are that the track is equal to Money for Nothing, and the artist is equal to Dire Straits. Right? So I make that call, and pretty quickly it comes back with the song. And you can see there's all those extended attributes. Spent 8 weeks on the top 10. It spent 13 weeks on the top 40. It made a high of number 1. Right? Now you can also do queries not against the whole index, but against just the hash key of the index if you want to. So rather than looking for the artist in the track, I can look for just the artist. And I do the same request, and again, pretty quickly it comes back with 7 items.